Today I'll talk about Buckingham's pi theorem or the Buckingham pi method for dimensional analysis. So first, what is Buckingham pi theorem or the Buckingham pi method? So Buckingham pi theorem is also known as Buckingham pi theorem or Buckingham pi method. It is a mathematical theorem used in dimensional analysis to determine the functional relationship between physical variable in an experiment. It allows you to express a relationship among the variables in a dimensionless form, which simplify experimentation and analysis. Now, what are the application? So, dimensionless modeling in fluid mechanics and heat transfer. So, dimensionless modeling in fluid mechanics and heat transfer. Then determining scaling law for physical phenomena. Then simplifying experimental setup and data analysis. Creating dimensionless group for modeling and prediction. Studying geometric and dynamic similarity in engineering. Understanding behavior in complex system with minimal parameter, that is very important. And then developing empirical equation from the experimental data, and finally improve design and performance optimization in engineering. So these are the application of Buckingham pi method or Buckingham pi theorem. Now, what are the steps for Buckingham pi theorem? Step number 1, list all variables in a system. So list all variables, that is number of variables is n. So here begin by identifying and listing all relevant variable involving the problem. This includes both dimensional and non-dimensional constant. So here both dimensional and non-dimensional constants resulting in a total of n variable. So first list all variables and count that variables. Step 2, express variables in a basic dimension. So what are the basic dimension? So express each of the variable in terms of basic dimensions such as mass, length and time, means fundamental dimension. These steps help to determine the dimension exponent for each variable, resulting in a set of m expression. Now how many fundamental or basic dimension is there? So that is also required. So that has to be counted, and so that is counted as a m, so that that m expression can be set up. Now step number 3, determine the required number of pi term. Now so here we are doing Buckingham pi theorem. Now how many pi term will be there in that particular problem? So step number 3, determine the required number of pi term, that is k number of pi term. How do we find out? So now according to the Buckingham pi theorem, the number of dimensionless pi term you need is equal to the difference between the total number of variables and number of expression you derived in step 2. So that this gives you the required number of pi term denoted as a k, means here k will be, so that is n minus m. So that will be the number of pi term. Now step number 4, now select the repeating variable. Now how many repeating variables in that problem is there? So that we have to select. How do you select repeating variable? That is not correct. So how do you select the repeating variables? So now here choose a set of repeating variables equal to the number of reference dimension, means fundamental dimension. Now remember, so here how many numbers of fundamentals dimensions are there? So same number of repeating variable we have to select. Okay, and these repeating variables serve as the basis of forming dimensional pi term. Now how do you select the repeating variable? So that is very important. So how many number of repeating variable will be there? So repeating variable will be number of fundamental dimension, so that is m. So whatever fundamental dimension we have, so that number of repeating variable will be there. Now how do you choose how do you select repeating variable? How to select repeating variables for Buckingham pi theorem? So number 1, include all fundamental dimension. The repeating variable should be collectively cover all the fundamental dimension relevant to the problem. So here m in total. Exclude dependent variable. The output parameter or dependent variable of the physical phenomena should not be part of the repeating variable. That is number 2. Point number 3, diversity of the properties. Choose repeating variable that represent different physical properties such as geometric flow properties and fluid properties. This diversity helps ensure that the repeating variable don't form a dimensional group. Means in the repeating variable, one variable must be in geometric, another is flow, another is fluid properties. Step number 4, balance the fundamental dimension. The repeating variable together should have the same number of fundamental dimension as determined in the problem. Avoid dimension overlap. Ensure that no two repeating variable have the same dimension, as this can lead to the redundant pi term. Now common choice, that is very important. In fluid mechanics problem, common choice of repeating variable often combines like dv rho or lv rho or dv mu or lv mu, where d is the characteristic dimension and v is a characteristic velocity, rho is fluid density, L is another characteristic length, and mu is fluid viscosity. So you have to remember. So when you choose repeating variable, that may be combination of all these. Okay. Now when I solve one problem, I will show you what are the repeating variable. Now you know. So step number 4 is the select the repeating variable, and how to select repeating variable I told you, I discussed in this slide. So next, step number 5, so form pi term. Okay, so create pi term one by one. Each pi term is formed by multiplying one of non-repeating variable by the product of repeating variable with each raised to an exponent that ensure the combination is dimensionless. So now step number 6, so repeat for non-repeating variable. Continue the process in step 5 for each remaining non-repeating variable until you have formed the required number of pi term. So step number 7, check dimensionality, means whatever pi term we'll get, whether that is dimensionless or not, that we have to check. And step number 5, express the relationship. So whatever pi term we'll get, so one pi term will be function of other pi term. So that is the relationship. Okay, now I am taking one problem and going one by one. So example is here. So consider pressure drop del P in a tube that is depend on length of the L, hydraulic diameter D, surface roughness epsilon, with fluid of density rho, viscosity mu, moving with average velocity v. Now using Buckingham pi theorem, obtain an expression of pressure drop del P. So now these are the parameter variable. So we are considering pressure drop in a tube. So that is depend on length, hydraulic diameter, surface roughness, fluid density, viscosity, moving with the average velocity. So these are the parameter. Now we have to find out one expression del P, that is pressure drop, using Buckingham pi theorem. So now we are going one step one by one. Okay, so step number 1. So we know step number 1, list of all variables, right? So this is the problem. Okay, so we have to list the variable. So first one variable pressure drop, length, diameter, surface roughness, density, viscosity, and average velocity. 1, 2, 3, 4, 5, 6, 7. Now here, so step number 1, list of all variable. So pressure drop is one variable, tube length is d, hydraulic diameter, surface roughness, fluid density, mu, fluid viscosity, and then average velocity. So here number of variables is 7, as there are 7 independent parameters. Okay, so 1, 2, 3, 4, 5. So here 7 variables are there. Okay, so that variables number is n is equal to 7. Next, step number 2, express variables in basic dimension, that we have to express. Now here, so we know that unit here is that the dimension. Okay, so now we know that unit of the del P, Newton per meter square. So from that we can get the dimension m L to the power minus 1 to the power minus 2. Dimension unit of length is meter, so dimension is capital L. Dimension of D, that L, again surface roughness L, that unit of rho kg per meter cube, so m L to the power minus 3. Okay, and mu is kg meter, kg by meter second, so that is dimension is m L to the power minus 1 to the power minus 1, b L to the power minus 1. So here fundamental dimension, so in terms of L, T and m, so these three means in that all these variable, so three fundamental variable are there, so m is here 3. Now next step we have to calculate pi term, right? Determine the required number of pi term. So pi term will be here, so k is equal to n minus m, that is n is equal to 7 minus 3, so 4 pi term numbers, that is 4. Now select repeating variable. Okay, so choose repeating variable equal to the number of reference dimension, which are mass, length and time. So common choice of fluid mechanics problem are here d, v, rho. So these are the here the repeating variable. Okay, so this d is a geometric properties, v is flow properties and rho is fluid properties. Okay, so one should be geometric, another will be fluid flow properties, another is fluid properties. Okay, geometric, these properties should be there when you select repeating variable. Here I am selecting d, v and rho is a repeating variable. Now next step is 4 pi term will be there. So here repeating variable is d, v, rho, a non-repeating variable is del P, L, epsilon, mu. Okay, so let's form the dimensional pi term. So phi 1 will be, so repeating variable d, v, rho, a1 into v, d to the power a1, v to the power b1, rho to the power c1 into, so these three repeating variable into one non-repeating variable. Okay, so pi 2 second, so again pi 2 will be d to the power a2, v again, so these are repeating variable, again this is multiplied with one non-repeating variable. Similarly pi 3, so epsilon is the non-repeating variable, and pi 4. So here every pi term a1, b1 and c1 are the exponent for pi 1, a2, b2, c2. So we have to find out a1, b1, c1, and based on that we can easily calculate what will be the pi term, that pi term will get. So a2, b2, c2, a3, b3, c3, a4, b4, c4. So these are all the exponents. So we got pi term 1, pi term 2, pi term 3, pi term 4. Now we have to find out the exponent, and after getting exponent we can easily form that pi term. Now how do we get that pi term? So verify here. Okay, so step number 7. So here del P dimension we know. Now first pi 1 is, we know that here verify the pi term are dimensionless. So here we know that pi term are dimensionless, and by ensuring that sum of the exponent for each fundamental dimension is 0 in each pi term. Okay, so now here, so pi 1 is equal to, so we have to put the dimension. So dimension of d, that is L to the power a1, L, b, L, t to the power minus 1, b1, m, L minus 3, c1, and then del P dimension we know that is the dimension, so m minus 1, t to the power minus 2. Now exponent for each fundamental dimension is 0 in each pi term, so we can write that m to the power 0, L to the power 0, t to the power 0 is equal to the right hand side, this side, right hand side. Now we have to, as in that left hand side, that m power is 0, so we have to match with that. Now solve that for now solve for the exponent for mass. So left hand side 0 is equal to c1 plus 1, so c1 is equal to minus 1. For length, left hand side is 0 and right hand side a1 plus b1 minus 3c1 minus 1. So from that we have to calculate that c1. Now so we got that c1 here. Now here that a1 and b1 we don't know, but c1 we know. But for time we know that 0 is equal to minus b1 2, so from here we can easily calculate b1 is equal to minus 2. Now if we plug a c1 and b1, we can easily get a1. So from we know 0 is equal to a1 plus b1 minus c1 3c1 minus 1. So from that a1 is equal to minus b1 plus 3c1 plus 1. So if you plug c1 and b1 value, so a1 will be 0. If a1 is equal to 0, now we know that pi 1 is equal to d to the power a1, b to the power b1, rho to the power c1 into del p. Now a1 is 0, b is minus b1 is minus 2, and rho 1 is minus 1. So now we got that pi 1 del p by rho v2 square. So if you check that, it is a one dimensionless number. Okay, so that is del p by rho v square. So pi 1 we got. Now similar way, so this is the dimensionless number. Similar way we can calculate pi 2 also. So that is pi 2 is equal to d to the power a2, b to the power b2, rho to the power c2 into l. So now we can put all these dimension of d, v, rho and l. So that is l to the power a2, l t to the power minus 1 into b2, ml to the power minus 3, c to the power c2 and l. Now we know that exponent of for each fundamental dimension is 0 in each pi term, because pi 2 is a dimensionless number. So from here we can write m to the power 0, l to the power 0 and t to the power 0, because from here to here, because pi 2 is a dimensionless number. Now we have to equate all this exponent. Now solve for the exponent. So now we can write m for mass, that's 0 in the left hand side, and m is c2, so c2 will be 0. And similarly for length, 0 in the left hand side, a2 plus b2 minus 3c2 plus 1. Now c2 value we know, but here a2 and b2 value we don't know. But for time, for here 0 is equal to minus b2, so b2 is 0. So now if we plug c2 and b2 in that equation, okay, in that equation, so we'll get 0 minus 0 is equal to a2 plus b2 minus 3c2 minus 1. So from here a2 will be minus b2 plus 3c2 minus 1. So if we plug all these b2 and c2 value, so a2 will be minus 1, b2 is 0 and c2 is 0. Now pi 2 will be d to the power minus 1, v 0 and rho 0 into l. Now from here we get pi 2 is actually l by d. So that is also dimensionless number, because l dimension is l, d dimension is l, that will be cancel out, okay, and that will be give 1. So now pi 2 will be l by d. Similarly pi 3 will get pi 3 is nothing but here, so d at 3, d to the power a3, v to the power p3, rho to the power c3 and epsilon. Now we put all these dimension, and then similar way we know that exponent for each fundamental dimension is 0 in each pi term. So left hand side will be m to the power 0, l to the power 0, t to the power 0, m c3 into la3 plus b3 minus c3 plus 1 and t minus b3. Now solve for the exponent. So from that, so mass left hand side, that is 0, and here c3. So from that c3 is 0. Now again for length, so left hand side is 0, and then it is total the exponent of l, so a3 plus b3 minus 3c3 plus 1. And for time, 0 minus b3, so b3 is 0. Now if we plug c3 and b3 in that for length equation, so that will give a3 is equal to minus 1. So from that we know exponent a1 is equal to minus 1, b1 0, c1 0. So again so we can get pi 3 is equal to d to the power minus 1, v0 and rho to the power 0 epsilon. So from here we can easily get pi 3 epsilon by d. So this is another pi term, so dimensionless number. Now finally pi 4. So pi 4, so we know pi 4 is equal to d to the power f4, v to the power b4, and rho to the power c4 in mu. Now again we plug all these dimension. Okay, so if we plug all these dimension and then put all together in the exponent. Okay, and we know exponent for each fundamental dimension MLT is 0 in each pi term, because pi is a dimensionless number. So left hand side m to the power 0, l to the power 0, t to the power 0, and then we calculate, we also m to the power c4 plus 1 means if we put together of that exponent of m, l exponent of l and exponent of t, so we'll get m to the power c4 plus 1, l to the power f4 minus b4, and minus c3 c4 minus 1, and minus b4 minus 1. And if we do that and solve for the exponent, so we'll get the left hand side that mass exponent is 0, and right hand side c4 my plus 1, so c4 is equal to minus 1. For length, that left hand side is 0, f4 minus, okay, so this is I think minus, okay, minus and then minus 3c4 minus 1, and t is equal to 0 minus b4 minus 1. Okay, so from that we can get that b4 is equal to minus 1. Now if we plug b4, this is so I think okay, I have to check again. So l, okay, so this is plus, okay, good, got it. This is plus, this is also plus, correct, this is plus b4. Okay, so f4 plus b4 minus 3c4 minus 1. So now f4 will be minus b4 plus 3c4 plus 1. Now if we plug all this value, so f4 will be minus 1. So ultimately if we so here exponent f4 is equal to minus 1, b4 is equal to minus 1, c4 is equal to minus 1. Now if we plug all this pi 4, that is d to the power minus 1, v to the power minus 1, rho to the power minus 1 into not del p, that is mu. Okay, that is wrong. Okay, so now if we do that, okay, so we'll get pi 4 is equal to mu d rho into v. Okay, so that is another that pi term. So that is nothing but 1 by re. So we know re is equal to rho d v by mu. So that is mu by d rho v means 1 by re. Now that is step number 7 is over. Now finally step number 8, express the relationship. So that is pi 1 is a function of pi 2 to pi n minus k. So we have to do that. So pi 1 we get del p by rho v square, pi 2 l by d, pi 3 e epsilon by d, pi 4 mu by dv. So pi 1 is equal to f of pi 2, pi 3, pi 4. Now we plug all this rho v, del p by rho v square, f of l by d, e by d into epsilon mu by d rho v. Now d rho v d by mu is Reynolds number, and e by d is relative roughness. Okay, so now ultimately we'll get that del p by rho v square is equal to f l by d epsilon by d and 1 by re. So after doing the Buckingham pi theory, we got the relationship of del p. So del p by rho v square is equal to function of l by d epsilon by d and 1 by re. That's it. Thank you.